Okay, assalamu alaikum. I've been asked by one of my students to do a review on the spring and friction forces, and I've decided I was going to do it. Anything to help my students. Remember what I always say, I can teach you, I can't learn for you. So I will do the review, but please make sure that you've got a pen and paper and a calculator, and let's get learning. Okay, multiple choice questions. This is the review sheet, obviously. Which statement about static friction is correct? It acts when there is no motion between the surfaces. Absolutely, that's true, because static friction has to do with objects not moving. But let's just, for physics sake, let's look at the others. It depends only on the velocity of the object. It doesn't depend on the velocity of the object, because the object has to be static, as in not moving. It decreases as the weight of the object increases. In fact, the opposite is true. When the weight increases, it increases. Or when the weight decreases, it decreases. Because remember, friction is equal to mu multiplied by the normal force. And the normal force is made of mass times gravity. So that is essentially the same as weight. Okay, so if the weight force increases, then that increases as well. The normal force increases. And if the normal force increases, then friction increases. Okay, it is independent of the roughness of the surface. That is also incorrect. The roughness of the surface, that's another way of saying the friction coefficient, right? So that is the roughness of the surface. So it's definitely dependent on the roughness of the surface. Ice on ice isn't going to have the same friction coefficient as metal on rubber. Of course, things have different friction coefficients depending on their roughness, the roughness of the surfaces that are in contact. Okay, number 2 says, if the coefficient of friction between the block and the surface is 0.4 and the normal force is 25 newtons, what is the frictional force? So we are looking for frictional force. That's what the small f stands for, friction. The big F stands for force. And that is equal to mu multiplied by normal force. Now, mu looks like that, in case you're wondering. Mu multiplied by normal force. And I have the friction, the coefficient of friction, which is 0.4. So that's mu. And the normal force of 25. So they didn't give me the mass this time. They gave me the normal force straight away. So obviously the answer is going to be 10 newtons. Always a good idea with multiple choice questions. Always a good idea to actually not look at the questions to begin with, if you can, and work it out and then look at the choices. So you've got the question, you've got the choices. Try and not look at the choices. Actually work out the problem, work out the answer, and then look at the choices. Just makes it easier. Okay, question 3. Which combination of material typically has the lowest coefficient of friction? The lowest coefficient of friction. So that's going to be something that slides very easily and doesn't have a lot of friction. So it's not the first one. That has a lot of friction. The second one is certainly very low. Plastic on metal, that's relatively low, depending on which way you look at it. Wood on glass. So certainly the lowest is ice on ice. Okay, let's keep moving. Oops. What happens to friction if the surface area of the contact increases? So as a matter of fact, you might be inclined to say that friction changes with the surface area, but it doesn't change. Okay, so does it increase, does it decrease, does it remain unchanged, or is it independent of the coefficient of friction? So we know it's not independent of the coefficient of friction, and it doesn't decrease or increase, it just remains unchanged. And the reason for that is this. So let's say, for example, we have a 1 kilogram block. So this is 1 kg. And this is the surface that's in touch with. Okay, so this is some sandpaper or whatever. Now, obviously, there's quite a bit of friction between the block of wood and the sandpaper, right? Now, what if I take the same block of wood and I flatten it and I make it like that? It's still 1 kilogram, but now the area of contact is a lot more. Okay, does that mean the friction has now increased? No. You see, there's something called pressure in physics, and pressure is reliant on force over area. And so the force in this case is going to be the weight. So let's just, for ease sake, let's make it 10 newtons, yeah? So this is 10 newtons, and this is 10 newtons. Now the force is 10 newtons because it's equivalent to the weight in this case. So the force over area is going to give me a number. Now I've increased the area over here, right? But what I've done is I've decreased the contact between the surfaces. How is that so? You see this here, if I could do a side view, this is how close it is to each other. This here, this is how close they are to each other. So there's a bigger gap here. So basically this is what happens. If you increase the surface area, you decrease the pressure because you've distributed it over a wider area. And so therefore the friction actually remains unchanged. So as the surface area increases, the pressure or the area of contact, the normal force decreases. And so it always remains the same. You can increase the surface area, but you will lose some of that normal force. Or you can decrease the surface area and make it such a smaller, narrower place, like in this case here, but then you'll make the contact a lot more, okay? So that's why. But, you know, you don't need to know the reasons. You do need to know that friction is independent of surface area. It doesn't depend on surface area. Let's keep moving. A force of 15 newtons is applied to stretch a spring by 0.3 meters. What is the spring constant? So spring forces is going to equal K or negative K multiplied by the change in length, okay? And since we are looking for, what are we looking for? We've got the length, which is 0.3. So that's like negative 0.3 since it's going downwards. So that's going to be 15 divided by negative 0.3, which is negative 50, or 50 if you prefer. So that's the answer, okay? It's just looking for the magnitude, the size. So it's going to be 0.3 divided by, 15 divided by 0.3. Because you've got that, which is 15, and that's 0.3. So it's 15 divided by 0.3, which is going to be 50 newtons per meter. What does the coefficient of friction depend on? The roughness of the surface. It depends on the weight of the object. Yeah, it does depend on the weight of the object, the nature of the surfaces in contact, the speed of the object, and the size of the surface area. So friction itself depends on the roughness of the surface or the type of material multiplied by the normal force, which is equivalent to the weight force. But they're not asking for friction. They're asking for coefficient of friction. So they're asking for this only. What does this depend on? And this depends on, that's the most terrible mu I've ever drawn. And this depends on the type of material only. That's all it is. That's the roughness of the surface. So it's the type of material that's being used, whether it's rubber or ice or anything like that. The unit of the coefficient of friction is what? Well, okay. So once again, I want you to look at this. What's the coefficient of friction? So force equals coefficient of friction multiplied by normal force. What's the unit for? Let me just rearrange that. So mu is going to equal force over N. What's the unit for force? Newtons. What's the unit for normal force? Newtons. Newtons and newtons will cancel out. There is no unit here. So let me just give you another example. Speed equals distance over time. Now, what's the unit for distance? Meters. What's the unit for time? Seconds. So speed has a unit of meters per second, right? That's all it is. It's that divided by that. So mu is force over normal force, which is newtons over newtons, so it doesn't have any units dimensionless. A rougher surface will generally have higher coefficient of friction, lower coefficient of friction, no effect or what? It's going to have a higher coefficient of friction, obviously. Okay, that's the whole idea of coefficient friction. Coefficient friction means how rough the surface is. If a spring stretches by 0.2 meters under a force of 8 newtons, what is the spring constant? So once again, always write the formula, just makes things easier. You don't have to for multiple choices, obviously, but I'm just saying, not for to get the mark, but I'm just saying it's really good practice. I always do it anyway. So 8 newtons equals mu multiplied by 0.2 meters. So obviously it's 8 divided by 0.2, which means 8 times 5, or 40 newtons per meter, right? Okay, let's move on. Doubling the force applied to the spring will do what? Well, I can tell you right now, it's going to stretch it twice as much. But how can I prove that mathematically and analytically? And sometimes the students struggle with this concept. So let me show you how I do it. So doubling the force. So here's the spring force, okay? And that's going to equal K multiplied by delta L, or you can use, sometimes I see some books use X, or sometimes some books will use E for extension. It doesn't matter, it's all the same, okay? So we'll just stick to delta L. Let's just give it some numbers, yeah? So if I say, for example, that's 0.1, okay? I'm just going to do that, just make it up. And then I'm going to give it a force of 10, right? So what's going to be the extension? Well, here's the triangle. Force equals K times delta L, right? So if I give it a force of 10 and the K is 0.1, then the extension is going to be 100 if the force equals 10 newtons. Now, what if I change the force and make it 20 newtons and keep the K the same? So 20 newtons and K is still 0.1. What's 20 divided by 0.1? Well, that's 200. So I can see that obviously doubling it will stretch it twice as much. Okay? Which force is directly proportional to normal force? The weight force. Okay? The gravitational force. Okay? Obviously. Oh no, sorry. That's not proportional to it. That's the same as it. Which force is directly proportional to the normal force? They're asking for force is equal to mu multiplied by normal force. So frictional force is directly proportional to normal force. So if you increase the normal force, you increase the frictional force. But it's not the gravitational force. The gravitational force is independent of the normal force. They are the same, but they're not proportional to each other. So what's proportional to each other is the frictional force. As this increases, this will increase. And as this decreases, this will also decrease. So the answer is in fact B, the frictional force. Okay, kinetic friction acts before the object begins to move, while the object is in motion, only when there's no force applied or independently of the object's speed. Obviously, while the object is in motion, unlike static friction. And of course, it always opposes the motion of the object. Number 13, if a 50 Newton force is applied horizontally to a 10 kilogram block, and the coefficient of friction is 3, what is the net force? Okay, so the net force, F net, is equal to applied force, F applied, that just means applied force, minus the friction force, which is F friction. So we know the applied force is 50 newtons, and the frictional force is going to be mu multiplied by the normal force, which in this case is going to be 10 multiplied by 9.8. And the mu value is 0.3 because it tells us in the question. Okay. Now some of you might be asking, what did I get? Where did I get this from? And that's mu multiplied by mass multiplied by g, and mass times g is equivalent to normal force. Okay, so anyway, that's the answer. Let me work it out. 0.3 times 10, 0.3 times 10 times 9.81. So the answer is in fact 20. Okay, I apologize if the answer on the answer sheet is wrong. It is in fact 20 newtons. Okay. Next, which of the following increases the normal force on a block? The normal force is going to increase if you increase the weight on the block. Okay, if you increase the weight on the block, then increases the normal force, obviously. Decreasing the surface area of contact. Yeah, pulling the weight, the block upwards, no, that decreases it. Decreasing the coefficient of friction. Right. Okay, so technically it's the first one, obviously. So adding more weight will increase the normal force because that's the block. Weight down is equivalent to normal force up, which is a reaction force. Yeah, so that's the only way. If a force of 20 newtons is applied to push a block at constant velocity, what is the frictional force? Okay, so once again, we're asked to, in this case, it's going to be 20 newtons. The force of 20 is applied to push a block at constant velocity. Constant velocity. What is the frictional force? Okay, let's think about that one for a second. Okay, when do we have net force? We have net force when force of 20 is applied to what is its constant velocity? What is the frictional force? So if it's moving at constant velocity, the net force acting on the object is going to be 0, because force is equal to mass times acceleration, and if there's no acceleration, then there's no net force. Okay, so basically the applied force is going to equal the frictional force in this instant, and yeah, so that's because it's moving at constant speed. It's moving at constant velocity. So 20 newtons here, and the friction here is 20 newtons. And that's what's causing it to move it. It's either not moving at all in this instant, or it's moving at constant velocity. So since it's moving at constant velocity, it's equal to 20. The relationship between spring extension and force is force equals K multiplied by this. If this goes up, what's going to happen to this? It's going to go up, so it's linear. It's not inverse, it's none of that. It's linear. Right, the frictional force will be 0 when the object is moving, the applied force exceeds the maximum static friction, the surfaces are perfectly smooth, or there's no normal force. So obviously it's when the surfaces are perfectly smooth. So that means there's no friction between the surfaces. There's no ridges at all. The applied force exceeds the maximum static friction. There won't be static friction, but there will still be kinetic friction. Okay, so for that one, it's not quite true. Okay. Next, a spring with a constant of 80 Newton meters is compressed by 0.1 meters. What is the force exerted by the spring? Once again, force equals K times change in length. So the reason why I'm writing K and not negative K is because I'm not writing -1. Okay, so the length here is going down. So obviously, because it's stretching down, you can write -0.1, and then the K you would, find the negative. But I can't be bothered with that. I just know it's going to be the same. So negative will cancel and become positive. So it's just F equals K times change in length. So that's 0.1. That's 80 Newton meter times 0.1. So it's going to be 8 newtons. Okay. Simple as that. The frictional force does not depend on the coefficient of friction, the normal force, the weight of the object, the surface area in contact. It doesn't depend on that. Number 20, if the coefficient of kinetic friction is 0.2, the normal force is 100, what is the kinetic friction? Come on, guys. You should be able to do this now pretty easily. Mu multiplied by normal force. So that is going to be 0.2 multiplied by 100 newtons. So it's going to be 20. Okay, let's move on. A 6 kilogram block is resting on a horizontal surface with a coefficient of static friction 0.3. What is the minimum force required to overcome static friction and stop moving the block? Literally, like what we've been doing. So F equals mu times N. Now N in this case is going to be M times G. So it's going to be mu 0.3 multiplied by 6 multiplied by 9.81. So that's going to be a number, 0.3 times 6 times 9.81. So it's going to be about 17.7 or 18 newtons if you prefer. A 3 kilogram block is on a surface with a coefficient of friction of 0.25. What is the acceleration of the block if the force of 20 is applied horizontally? Okay, so in this case, you have to do just a wee bit of work. First of all, the coefficient of friction of this. So let's find out what the frictional force is going to be. So force of friction is going to be mu multiplied by normal force. So it's going to be 0.25 multiplied by 3 multiplied by 9.81. And the reason why we find that out first is that way we can find what the friction force is going to be and work out what the net force is going to be. So 7.36 newtons. That's what the friction force is going to be. Now I know the net force is going to be the applied force minus the friction force. Why is that? Well, think about it. If I'm pushing something and there is no friction, it's going to accelerate very quickly, right? Let's assume I'm pushing a box on some ice and I push it quickly because there is no slippage. There's no, friction. So it's going to slip very quickly. Okay, there's no friction. Now imagine if there was friction. Try to do the same experiment on wood, or try to do the same thing on asphalt. Of course, it's not going to slide as fast. The reason for that is because of this friction. So the net force is decreased, and therefore the acceleration is decreased. So I have to account for the friction. So once I have the friction, I can go applied force 20 newtons minus 7.36 newtons, and that will give me 20 minus 7.36, and that will give me 12.64 newtons. That's the answer to that one. Okay, that's the answer to that one. No, wait, that's only the force. That's the F net. They're looking for the acceleration. So F net equals 12.64. I still have to go that F MA. So then it becomes, this deserves more than 2 marks, to be honest. I think this deserves at least 3 marks. But anyway, so it's going to be acceleration equals 12.64 divided by 3. 4.2 meters per second squared. That is the answer. Okay? A spring is stretched by 10 centimeters when a weight of 50 newtons is applied. How much will it stretch if a weight of 75 newtons is applied? Okay, so 2 ways of doing this. One way, I'm just going to use a different color so you're not confused. One way is by using K value. So you can say, for example, F equals K multiplied by change in length, right? So if I apply 50, is going to equal K multiplied by 0.1 meters. And that's going to give me 50 divided by 0.1, and that's going to give me K is equal to 500. Now that's important. Once I know that, then I can use the formula again. I can say 75 newtons, which is what the question gave us, is equivalent to 500 times delta L, and I can find L, therefore change in length is equal to 75 divided by 500, and that's going to be 15 centimeters, or 0.15 meters. So that's one way of doing it, or if you prefer, 0.15 meters. The other way of doing it is just by looking at ratios. So 75 divided by 50 is 1.5 times. 75 divided by 50 is equal to 1.5 times. So it's going to be 1.5 times the stretch. So then 1.5 times 10 centimeters is equal to 15 centimeters. So there's multiple ways of doing it, okay? And this only works because they're linear. Next, a 10 kilogram crate is on a horizontal surface with a coefficient of friction of this. What is the force needed to start moving the crate? So obviously the force needed to start moving the crate is going to be equivalent to the friction, because once we overcome the static friction, then it's going to start moving. So it's going to be is equal to mu multiplied by normal force, which is m times g, and that's going to be 0.5 times 10 times 9.81, which is going to be approximately 50. So it's just below 50. Times 10 times 9.81, 49 newtons. Next, a spring with a spring constant of 100 is stretched by 0.2. What is the force applied? Force equals k times change in length. So it's going to be 100 force, 100 times 0.2, which is 20 newtons. Okay, and finally, number 6 is asking you to do an object is pulled with a force of 30 newtons and solved with a coefficient of this. What is the net force acting on the object? So F net is equivalent to F applied minus the friction force. So it's going to be 30 minus whatever the friction force is, which is mu times 5 times 9.81. Mu is given 0.4 times 5, which is the mass, times gravity, which is 9.81. And that's going to be 30 minus 0.4 times 5 times 9.81. So it's going to be 10.4 newtons. Let me just check that. 0.4 times 5 times 9.81. 30 minus answer. Wait a minute. 0.4 times 5 times 9.81. 30 minus answer. Yeah, so that's correct. And there you go. That's it. If you have any other questions, please remember, brain, body, boss. Okay? Try and figure out the answer yourself. Look at the book. Look at your notes. Use ChatGPT if you have to. Google. And then the second one is by calling up a friend and ask them to explain it to you. And the third one is by sending your teacher a message and asking them what the question is. Okay, thank you. All the best. Take care.